interface issue. Troubleshooting, it will also have the language selection and things like that on it. Actually. Does it work? Okay. Yeah, okay, okay, that's cool. Okay, I don't know if the... anyway. Okay, but to do a reaction, so we're going to do a quick one at our system. This is basically a 60 bar autoclave. But it's empty, so you know it's going to take a while to fill up, so we'll do a 10 bar one first. Okay, so it's set up, the valves are open, right? So everything's set up, we can just go from the start. So you just basically set reaction pressure, and then you have the set vessel gas fill rate. So we'll do what most people want. Okay, so we'll set 10 bar, so you just set 10 bar, okay, and then basically you'll do what most people will do, and you'll just set, okay, set 1 litre per minute, okay, fill rate, and then you press start, okay, and it'll go through some different checking and everything like that, okay. And then what it will do is, what you'll see, it will start to produce the hydrogen inside, and then it will run through into there as well. So you can now actually see the flow rate. So the mass flow controller is actually increasing the flow rate of the hydrogen which is actually being generated, okay? And what it will do is it will sort of rush into there, or keep on increasing, and then it will go up to 10 bar, and then it will stop. And then basically, in the next version of the software, not this one, but basically it will look at the 10 bar, and if the hydrogen is consumed, it will keep feeding hydrogen to maintain the pressure, okay? And it will do that efficiently, that's all. Okay. So as you can see, it's a very simple use. It's very difficult to actually have some sort of excitement for that, okay? Okay. So there you go. Now you can actually see that basically it's at 1 litre per minute. Okay. And then basically you just have to wait for it to fill up everything. So if it's going, you can see it's starting to creep up already from up to 1 bar, and then it's just a case of waiting. So what will happen is that the person won't need to wait here, so they just need to make sure that the pressure's started to rise. What they can do is they set up, and then they can just walk away. And the system will basically look and see at the temp pressure. You can see it's rising above 1 bar now already. You can see that it can feel like a 1 bar there already, so it's generating. The reason why it's taking so slow, but you know, it's one of the autoclaves, so it's a bit, the autoclave's a bit temperamental, you know, so not the system itself, but the autoclave's a bit temperamental, is that we didn't want to discredit, so it's completely empty. Typically in a reaction it's going to be like 2/3 full, so the actual volume inside will be like 300 milliliters, and so it will be a lot faster. But this is what happens if you fill a completely empty 1 liter per minute, okay? So you can see there's the flow rates, so the actual setting is the 1 milliliter per minute, and as you can see, you can probably use this as more example when it's just filling up, okay? So as I said, if it was full with a reaction, then it would probably be at least 3 times faster, let's put it that way, okay? And you can see the voltage, you know, and basically how much the cell is being used, but that's completely. So the lifetime of the cell, so at the moment that's basically hours and minutes, okay? So at the moment, in this version of the software, which has been uploaded, it's been tested for about 5 hours. So. And then you have the time, actually at the time there as well, so how long the system has been running, and then you have like the H2O level as well.
And if there is no water,
it shuts down automatically. So there are a number of different safety things in there which we've built in. You know, hydrogen sensor is just one. There's also a water leak sensor at the bottom as well, so if there's any water at the bottom, and that will also detect it, so if there's any leak inside it, so we thought that was also very important. And so there's also mechanical issues, so it would never blow up because there's like something called a relief valve. So if it ever gets up to say 100, what's the pressure of the relief valve?
115 after the sound.
120. Okay, so it won't go higher than that. So it'll go, and then it will basically also shut down as well from that. Okay, so yeah, so it's filled up pretty much the simple one. So it's more or less in correlation with the system here as well. Okay, what we're going to do now quickly is show you can run with a flow system. So we'll just stop this, stopping now anyway, okay? So it's reached the 10 and then it just basically does that, okay? And what we'll do is we'll wait for it to stop. And anyway, what we're going to do is we'll show that it's compatible with the Phoenix, okay? So I guess some of you know about
50 bars, okay? And the flow rate should be
300 mils per minute, okay? So tell me when you're ready.
Okay, we are waiting for the liquid pressure first. Yes, the system is still filled with the H-Genie from the test.
Okay. Yeah, sure. It's okay.
And in fact, there is no consumables at home. There is no
System, so it has to build up enough hydrogen inside and then release 300 mils per minute and then carry on increasing the pressure to maintain that. So that's what it's going to do. It's up to 24, but it can fill up to 100 bar pretty quickly. Where's Antal?
Left.
Antal, but basically it's apparently to fill up from 1 to 100 bar, it's inside pressure is only like 5 to 10 minutes max. Inside it doesn't take, so it's even less than I guess the Pro, which takes quite a long time. So in this one it's obviously a lot faster. And you can see there, and this one it's flow, so basically what will happen is it will reach 50 bar, it will release into the system and you'll see the bubbles coming out. Basically.
Yeah, after a short time.
So I have to talk to you about next week, because next week will be at Aegis. So they would like a demo of that. So next, one of the things that we'll be showing in this later on in the next version, but it's not really this, it's obviously a graph to show that how much hydrogen is being evolved and things like that, so people can log. I think it's more interesting for the batch reactor, because what they can see is they can see it fill, and then they can actually see from the point of the pressure how much hydrogen is consumed in the reaction. In flow, what you'll see is just a general straight line because it's on that side. But with flow, what you'll be able to do is that you'll be able to change the parameters on the fly. So you'll be able to stop it quickly, and then change to another pressure, and then restart it, and it can. So you can do optimization more or less on the fly. Okay.
And it's already available, the graph for the batch?
No, that will be coming next year.
Okay.
So next year, basically, there will be obviously an update of the software featuring the graph. You will have the auto-filling water system and the dry cart. The dry cart will be probably the first one because it was very simple. We've almost finished that. The auto-filling system, I think you can buy those already, actually. So yeah, if you can send me some links, because I don't know that.